Hello everyone, this is Dr. Pooja Johari, your original guru of biochemistry. Now today we are going to start up with a very interesting topic, again a very important topic in biochemistry, carbohydrates. Now, what all we are going to cover in this particular topic? We would be focusing mainly on the definition, very important. We would be covering the properties, or basically the chemistry of carbohydrates. And then after this, we are going to study the metabolism. This will be the pattern in all the respiratory foodstuffs which we eat. This is how we are going to cover up proteins and amino acids, lipids, and after that we will be covering up the vitamins and minerals. So if we talk about the metabolism, we can say that it will include the digestion and absorption of carbohydrates and what happens when the carbs enters inside the cell. And after this, we will be covering up with the inborn errors of metabolism. Right. So let's start up with first of all the definition and the chemistry of carbs. So if we talk about the definition, always remember the earliest definition of carbs was that they are the hydrates of carbon. Then they are having carbon, hydrogen and oxygen in the ratio 1:2:1. Right, just C6H12O6 is there. But the widely accepted definition of carbohydrates is that they are the polyhydroxy derivatives of aldehydes and ketones. Polyhydroxy derivatives of aldehydes and ketones. Because aldehydes and ketones are basically the functional groups. So whatever the functional group is present in a particular carbohydrate, it is going to give that property to it. Just glucose is there, fructose is there. We all know that glucose is aldohexose, aldehyde is the group, and fructose is a ketohexose where ketone is the functional group. So we can say that they are the polyhydroxy derivatives and CnH2n like this. Okay. Now, if we talk about the classification of carbohydrates, the most widely used pattern, or you can say, is that they are divided into aldoses as well as ketosis. So aldoses means aldehyde as the functional group and ketosis where ketone as the functional group. So we can say this classification is as per the functional groups. Now, if we talk about, and always remember one thing, that this carbohydrates will always start from 3 carbon atoms. So I can say that on the left hand side we can write the number of carbon atoms. Okay. So if it has 3 carbon atoms, it is a triose sugar. So automatically aldose will be, the example of aldotriose will be glycerol aldehyde. And ketone will be dihydroxyacetone. If we talk about 4 carbon atoms, it becomes tetrosis, 5 pentosis, 6 hexosis and 7 is heptosis. Example of 4 carbon is erythrose. So the ketonic derivative will be erythritulose. 5 carbon atom, we can simply say that ribose. and ribulose. Right. 6 carbon atom, we all are familiar with both the terms. Glucose, which is actually the hero in the body, which is the most important energy indicator, plus you can say glucose is the one which is the main carbohydrate which undergoes oxidation in the body. Glucose, and the corresponding one is fructose. And 7 carbon atoms mein it is pseudoheptulose. And the most interesting part to remember about this is aldoses and ketosis are linked as isomers with respect to one another, because this is a very important feature of all the carbohydrates. Whether we are eating fructose, whether we are eating galactose, or whether we are eating mannose, they have to be converted into glucose, which has to undergo finally oxidation, or they will merge themselves into those pathways which are actually oxidizing glucose. So I can say aldoses and ketosis are linked as isomers with respect to one another. Same as you are going to see glyceraldehyde and dihydroxyacetone phosphate, both are the intermediates of glycolysis and they are linked as isomers. And the enzyme also I have discussed in my video on enzymes. The enzyme is triose phosphate isomerase. Erythrose, erythrulose, ribose, ribulose. Now here one more thing is there, ribose, and one more is there, xylose, which is again a 5 carbon atom, 5 carbon sugar, and here it is xylulose. And you know the best interesting part is ribose and xylose, they are linked as epimers, which we will be discussing again the next segment. And here also ribulose, xylulose, they are linked as epimers. And glucose and fructose. Pseudoheptulose is the only important ketoheptosis which is present in the body, which is actually synthesized in the body by an alternative pathway of oxidation of glucose, which is hexose monophosphate shunt. Okay, so this is how we classify them as per the functional groups. Then second way of classifying these carbohydrates is as per the number of units. So if we talk about as per the number of units, we can simply classify them into 4 major classes. And what are these 4 major classes? We have been studying this classification for so long. So we can say that monosaccharides. What is this saccharide? From where this term of saccharides have come? Actually, carbohydrates are derived from sugarcane, and you can say the botanical name of sugarcane is Saccharum officinale. So that saccharide term is coming from that. So monosaccharide means single unit. If we talk about disaccharides, di means 2. So disaccharides will have 1 plus 1. Oligosaccharides have 3 to 10 monosaccharide units attached, and when it is more than 10, it becomes polysaccharides. So this is how we classify the carbs on the basis of the number of units. Now if we talk about monosaccharides, simple example we can say that glucose is there, fructose is there, galactose is there, and mannose is there, which are the 4 very, very important physiologically important sugars. Disaccharides mein we can quote the example of lactose, maltose, sucrose. Oligosaccharides mein stachyurose or raffinose. And coming over to polysaccharides, these polysaccharides are further divided into 2 subclasses. We can say that one is homopolysaccharides and second is heteropolysaccharides. And it is again clear from the word itself, homo means identical units and hetero means non-identical units. This homopolysaccharides mein you can simply say again Glucosons are there, which have only glucose, and fructosons are there, which have only fructose. And heteropolysaccharides is another altogether a different class, which are also known as GAGs, glycosaminoglycans. Right, and if we talk about glucosons, I can just give you the example. The most common example is starch, glycogen. Rest we will be discussing in detail also. And fructosons ka example is, there is only one example, that is inulins. So this is the brief classification of carbohydrates as per the number of units. And the previous classification was as per the number of carbon atoms. Okay, coming over to after classification, then we come over to the properties of these carbs. Properties are also very, very important, which there are certain facts in this which you people need to know. So under properties, again, what we are going to discuss, the most important property is isomerism, the most important one. So, first of all, we are going to touch isomerism. Second important property which we are going to cover is oxidation. And third important property which we are going to cover is reduction. So, we will be focusing on these three important properties: isomerism, oxidation and reduction. Now, we all have studied isomerism in our previous classes in detail. But here we will be focusing on the main forms which play a very, very important role in the body. First of all, because if we talk about isomerism, it's a never-ending topic. It's too vast also. But here we will be focusing only on those properties, only on those forms which are actually utilized by the body. Same is the case with oxidation, same is the case with reduction. Under isomerism, we are going to study the most important one, structural isomerism. We are going to study stereoisomerism. And we are going to study optical isomerism. Because most of the students get confused between stereo and optical isomerism. Okay, so if we talk about, first of all, then oxidation reduction we'll see after this. Now, if we talk about structural isomerism, very simple. First of all, beta, what is isomerism? Isomers are simply the compounds which have a same molecular formula but different structural formula. Simplest definition of this. So, if I talk about structural isomers, I can say that they have a same molecular formula but different structural formula. Right. And the example is glucose and fructose. And the basic difference is glucose is aldohexose and fructose is a ketohexose. Because if we draw the structure of glucose, it is like this. H double bond O, 1, 2, 3, 4, 5 and 6. H, OH, OH, H, HOH, HOH. Okay, and if we talk about fructose, it is CH2OH, C double bond O, 1, 2, 3, 4, 5 and 6. OH, H, HOH, HOH. And you can see that here the aldehyde is the group and here ketone is the functional group. We all know that ketonic group is never assigned position 1, it is always designed position 2, which is C2 carbon atom. Okay. So these are structural isomers, right? And we can simply say that aldo and ketohexose, and this is simply the open ring structure of glucose, or it is also known as, you can say open, this is open, because after this is Fischer projection also, and we all know that every molecule tends to grow in a stable conformation. So this can be converted into a cyclic one, which is Haworth projection as per the stability. But since here it is structural isomerism, so we can simply say that the difference is in the structures, right? Then second type of isomerism is stereoisomerism. Now, if we talk about stereoisomerism, isomerism ka definition is going to remain the same. Same molecular formula but different structural formula, but here the orientation will differ in the space as it is stereo. So I can say that differ in the orientation in the space. In space. Ab how can we judge the molecule ki what is going to happen in the space? So for that we need to know a reference molecule. If we have a reference molecule, we know a reference molecule, we can simply assign the conformation by comparing that reference molecule with other molecules. So here, that is why, the reference molecule becomes glyceraldehyde. And always remember, this is just because of this plain and simple reason, the carbohydrates always starts from a 3-carbon atom. Have you ever seen dioses? Dioses never exist. Only trioses exists. And this is why the reason is, proved here. So I can say that the reference molecule here is glyceraldehyde. Okay, which has how many carbon atoms? 3 carbon atoms. Now the question is, it has 3 carbon atoms, and if I have to write the structure of glyceraldehyde, I can simply say first carbon atom, second carbon atom, and the third carbon atom. CHO cannot change, CH2OH cannot change, only HOH can change. Okay, so if I have to draw a mirror image of this, can I write it like this? So this becomes the mirror image of this. And the another important thing is this carbon atom is also known as chiral carbon atom. So I can say that this carbon atom, or it has 1 chiral carbon atom. And what is a chiral carbon atom? It is that carbon atom on which the other 4 substituents attached are different. Okay, so if I have to write the definition of a chiral carbon atom, it is also known as asymmetric carbon atom. Chiral carbon atom, when all the 4 substituents attached are different. Okay. Now, if all the 4 substituents attached to a particular carbon atom are different, it is going to form a non-superimposable mirror image, which cannot be superimposed. And that is what is exactly happening here. So, see, you have to learn these things step by step. First of all, you should know what is the structure of glyceraldehyde. I won't recommend you to, remember the structure of all the carbohydrates. But yes, glyceraldehyde is a simple structure to understand, and it is important also, because if you look at the structure of glyceraldehyde, you can actually visualize what is happening. Okay, so if you see this particular structure, I can say that just now I mentioned there is a change in the position of only OH. CHO, CH2OH remains the same. So if OH group is on the right hand side, okay, as in the case of this, it will be known as D, capital D. Just keep this thing in mind, capital D glyceraldehyde. And if OH group is on the left hand side, it becomes capital L glyceraldehyde. So this is just capital D and capital L. So how do you define D? Capital D? Capital D glyceraldehyde is defined as that molecule in which OH group is always placed on the right hand side. And L glyceraldehyde is that molecule when the OH group is placed on the left hand side. Okay. And if we talk about the chiral carbon atom, all the 4 substituents attached are different, and always remember one thing, it is going to form non-superimposable mirror image. And whenever the isomers are going to form the non-superimposable mirror images of each other, they are known as enantiomers. Very important. So I can simply write it like this. Enantiomers are the isomers whose mirror images are non-superimposable to each other. Right. Example is capital D and capital L. So capital D and capital L are always linked as enantiomers. So to have a isomer which has a non-superimposable mirror image, it needs to be having a chiral carbon atom, because chiral carbon atom is a mandate. Okay. Now this is the structure of glyceraldehyde. How to say that in which form glucose is existing? So for this, simple concept is there. This is the second carbon atom, as you can see, 1, 2 and 3, 1, 2 and 3. This second carbon atom behaves as the second last carbon atom of the respective sugars. Jaise, for example, if I draw the structure of glucose, we know that 6 carbon atoms, 3, 4, 5 and 6. Right? So this 5th carbon atom is just like the second carbon atom of glyceraldehyde. Okay, so this is your second carbon atom. So if we compare this second carbon atom with 5th carbon atom, you can see that it is on the right hand side. So we will refer glucose as D-glucose. And that is why this glucose is also known as, just in hospitals we never search for D-glucose, we always search for dextrose. So you can just remember one thing, that D for dextrose, D for D-glucose. So glucose is mainly available in dextrose form, or it is more active in D form. It's not that L-glucose does not exist, it also exists, but the most stable form of glucose is D. And how we came to know? We are simply comparing the 5th carbon atom with the second carbon atom of glyceraldehyde, and that is why glyceraldehyde is also known as a reference molecule to give stereoisomerism to the respective sugars. And that is why we always say that D-glucose and L-glucose are linked as enantiomers. Right? So this is very important. This we have to remember. And this is stereoisomerism also. Now, on the contrary, similarly, if I am writing DNL glucose, so automatically it will come DNL galactose will be there, DNL fructose will be there, DNL mannose will be there. But you have to just remember one thing, that this is capital D. After this, I will be coming over to small d also. Okay. Now, coming over to the third type of isomerism, which is, ye kya hai? This is simply, you can say, stereoisomerism, where differ in the orientation in space, or I will just make it more clear, D and L isomers. which are commonly known as enantiomers. Now coming over to the third one, which are optical isomers. Now most of the students again get confused between these two terminologies. So the basic difference is that optical mane they differ in orientation with plane of polarized light. Just keep this thing in mind. So differ in orientation with plane of polarized light. For example, suppose if this is the solution and we are passing a monochromatic beam of light through this colored solution. Okay, I'll just make the solution like this, right? And if it is rotating, it can rotate in only two directions. Either it can rotate in right direction or it can rotate in left direction. So if it rotates in right direction, we call it as dextrorotatory and it is denoted by a positive sign. But if it is rotating in left direction, we call it as left in levorotatory and it is denoted by negative sign. Okay, but they are rotating. Okay, so whether it is in right direction, whether it is in left direction, so they are known as optically active substances. So both of them will be rotating the plane of polarized light, so they will be optically active. Up, if we mix the two forms, they are the molecules, they can be mixed easily. So what will happen? Positive is like this, negative is like this. Or if we mix the two forms, they will now become optically inactive. So they will be optically inactive. And since they are forming a mixture, so we will call this mixture as a racemic mixture. So again, this is very important. What is a racemic mixture? We can simply say that a racemic mixture is optically inactive. Why it is optically inactive? Because the positive dextro is cancelling the levo one. So these are the three very important type of isomerisms which are existing in the body. Okay, one is structural, glucose and fructose, stereo, D and L, and if we talk about this, we can simply say that optical means small d and small l, dextro and levorotatory. Then along with this, the molecules are there, so they will be going in a stable conformation. This is suppose if I am teaching you, if you are listening to the video, so automatically some will be just relaxing in the bed and listening to the video. Some students, it's again their mode of listening. They will just sit properly on a table and chair, but they will keep on changing the posture. Why? Because everybody tries to go in a stable conformation. Because if you are stable, if you are in a position to actually understand the video, you will be able to understand it in a better way. Same is the case with molecules. Whenever molecules have to give their maximum, they always tries to go in a stable state. Okay, so that is why we always say glucose also exists in a stable conformation. There will be keep on changing the conformation. Just say in your previous classes you have studied about chair and board conformation, then ENS, RNS, so many different ways of classifying them are there. But again, we are not going to dwell into that much, because here we will be totally concentrating on the things which are actually existing in the body. Okay, so the most important point which you have to remember in isomerism is anomerism or anomers. Okay, so first of all, you have to understand what are anomers. There are basically two terms, anomers and epimers. Both are different. First of all, what are these anomers? Anomers are those isomers which differ at C1. C1 means carbon. C stands for carbon, or C1 is actually known as anomeric carbon atom. Right. Now, if we talk about glucose, we all know that. I'll just give you one very interesting example. Again, you don't have to learn the structures, but yes, you should know, because if we are writing something in structures, it becomes easier for a person to understand. Okay? So, I can say that just now I wrote the structure of glucose, H double bond O, 1, 2, I'll just write it like this. This is fifth carbon atom, CH2OH. Okay, so 1, 2, 3, 4, 5, 6. Now see, if we talk about this particular structure, okay, this is simply Fischer projection or open structure of glucose. This particular structure can exist in two forms because the resonance is there. I can write it like this also, C double bond OH. It won't make any difference. The only thing is that double bond O will come here, double bond O will come here. So it's like a resonance is there. Okay, rest of the structure will be same. Now the question is that since this is open structure of glucose, or I will write just Fischer projection of glucose. Just now I told you everything tends to go in a stable conformation. So what will happen is there will be an interaction between first and fifth carbon atom. Means water molecule will be given out. So I can say interaction which will be between the first and the fifth carbon atom. No matter what happens, there will be a removal of water. So I can say minus water, minus water. What will be the resultant? The resultant will be, now if O group is present here or O group is present here, so the change will be only at the first carbon atom. So if I have to write the structure, I can simply write the structure like this. In one condition, this is carbon 1 now, OH, rest everything you will see it will be the same. 3, 4, 5 and 6. And same if we write the structure here. Here you see first carbon atom mein OH goes up, second, third, CH2OH, H. So the main change is at the first carbon atom. First carbon atom here is placed downwards, there it is placed upwards. So what we will do is, if OH group is placed downwards, we call it as alpha D glucose. And if OH group is placed upwards, we call it as beta D glucose. Right. So alpha and beta. Here there is no capital D, capital L, no small d, small l. Here the basic difference is between the first carbon atom, which is the anomeric carbon atom. So I can simply say that alpha D glucose and beta D glucose are the anomers. Why? Because they have a change only at C1 atom. This is very important to understand, right? And on the other hand, I can also say that the C1 carbon atom is free, because whenever we assign any functional group to any of the molecules, whatever I would say the properties that molecule is exhibiting, that is due to the presence of that particular functional group on it. So if glucose is giving some kind of characteristics, it is due to the presence of that aldehyde. If fructose is giving some properties, it is due to the presence of that ketonic group. So I can simply say that anomeric carbon atom, if it is free, means if it can react or if it can reduce any of the chemical reagent, we will call them, we will call that particular sugar as reducing sugars. And what is the clinical significance of this? reducing sugars are the most important abnormal constituents of urine. If in urine sugar starts appearing, it is simply an indication of diabetes mellitus. Very, very important, because urine analysis itself plays a very important role in the diagnosis of the diseases, because that is what is the importance of biochemistry in medicine also. Be it any fluid in the body, be it serum, be it plasma, be it urine, be it cerebrospinal fluid, whatever fluid is there, it is having those molecules where reactions are occurring. Any injury, any kind of pathological disturbance in the body is going to increase that particular thing in the fluids or in the serum or in the plasma, which being medical professionals we have to detect. Okay, so these reducing sugars are very, very important diagnostic evaluation of DM. And what are reducing sugars? They are simply the ones which have a free anomeric carbon atom. What is an anomeric carbon atom? Which is C1. Okay, so I'll simply write, here I have written that anomers, alpha D glucose and beta D glucose, and the most important one is that the sugars which have a free anomeric carbon atom. Now every time I am not going to say which is an anomeric carbon atom. Whenever I take the name of anomeric, you should be able to now understand that it is nothing but C1. So the sugars which have a free anomeric carbon atom, they are known as reducing sugars. Right? Example. Just for your knowledge sake, I just keep one thing in mind, all sugars are reducing except sucrose and trehalose. Whether it is a monosaccharide, whether it is a disaccharide, even though for that matter polysaccharide, because polysaccharides में starch or glycogen, they have one reducing end, one non-reducing end. So we can't say they are non-reducing sugars. They have a reducing end also. So all sugars are reducing except sucrose and trehalose. So all sugars are reducing except sucrose and trehalose. Again, this is a very important point. So, सबसे पहले, what are anomers? We can say that anomers are the isomers which differ only at first carbon atom, and everything tends to go in a stable conformation. So, this Fischer form can be converted into alpha form, it can be converted into beta form. And those sugars which have a free anomeric carbon atom, they are known as reducing sugars. And one more I will write that reducing sugars are the abnormal constituents in urine. Of urine would be the more appropriate word. Of urine, right? Because excretion of, because small amount of sugar is always, given in urine because we are eating depending upon our dietary habits. But it is insignificant. But when the concentration of this increases, it means it crosses the renal threshold. It is known as glycosuria, or most commonly, which is the most characteristic important feature of diabetes mellitus. Okay, so these are what? These are simply the anomers. Then one more similar term with anomers is epimers. Now anomers तो क्या कर रहे हैं? They are differing only at C1 position. Epimers क्या करेंगे? They will differ at any other position except C1. C1 पे करेंगे तो they will be known as anomers. But if they are differing at any other position except C1, they will become epimers. So definition will be epimers, any other position, or you can say any other than penultimate carbon atom, which is C1. So any other position except C1. For example, And this is again a very important reaction which takes place in the liver. Epimerase is the name of the enzyme, and if this enzyme is absent, it leads to galactosemia. Okay, which again we will be discussing in the metabolism of galactose. So what happens is, epimers mein you have to just remember the example that galactose, which is again a monosaccharide, galactose is C4 epimer of glucose, and mannose is C2 epimer of glucose. Okay, so suppose if this is the structure of glucose, abhi I am not mentioning alpha D glucose or beta D glucose because that is differing at first position. Here we are just simply focusing on glucose. So, or you can say, chalo, you can keep it as alpha D glucose also, but here what I am going to differentiate between glucose and galactose and mannose. HOH, 1, 2, 3 and CH2OH. Okay, so this is first carbon atom, second carbon atom, third, fourth and fifth, and this becomes the structure of glucose. Chalo, I will write alpha D glucose so that you should not get confused. Now, if I have to write the structure of galactose, you see this is fourth carbon atom, and if I write the structure of galactose, it becomes like this. Everything you see will be the same. First, second, third, but on the fourth carbon atom, OH aram se it will go upar and like this, CH2OH. So this becomes the structure of galactose. But since OH group is placed downwards, so I can simply write alpha D galactose. You can further write the structure of beta D galactose where there will be shift in the first position. But fourth position pe OH will always be up. This you have to remember. And I will just name the carbon atoms also to avoid confusion. 1, 2, 3, 4, 5 and 6. There is no need writing 6 because 6 is clear, it is CH2. Okay. So this becomes galactose. And if we have to write the structure of mannose, mannose mein the difference is at C2. Everything will be the same. Second position pe OH will again go up. OH, but fourth pe it will be like this. Like this. So 1, 2, 3, 4 and 5. And this becomes, let me just highlight the second carbon atom, and this becomes alpha D mannose. So this is epimerization. These are the epimers, and this is the basic difference between anomers and epimers, right? So I'll just highlight this also. Any other position except C. So you can say that galactose is C4 epimer and mannose is a C2 epimer of glucose, but both are reducing sugars. Okay, that is what I told you in the starting also. All sugars are reducing except sucrose and trehalose. So this is all about isomerism, and here I will write one more thing. Epimerase enzyme, which is actually GAL, we call it as GALT also, galactose transferase, or it is actually uridyl transferase. It belongs to epimerase. GALT deficiency leads to galactosemia, which we will be again discussing in the metabolism of galactose in detail. So this is all about isomerism. Okay. Then the second property after isomerism is oxidation. Now, if we talk about oxidation, we all know that glucose as an aldehyde group, it will be oxidized. So I can simply say that, say if this is glucose, it can be oxidized in the presence of mild oxidizing agents. It can be oxidized in the presence of strong oxidizing agents. Okay, but the question is that when it is oxidized in the body, what is caused? So mild oxidizing agent mein this group is most susceptible towards oxidation. So we can simply say that aldonic acid will be produced or gluconic acid will be produced. Strong oxidizing agent mein both the groups will be oxidized. So it is going to form saccharic acid. But if this reaction takes place in the body, or you can say in vivo, where this group is oxidized, this group is not oxidized, it is going to form glucouronic acid. Very, very important. So I can say that glucose in the presence of mild oxidizing agents, in the presence of strong oxidizing agents, can form their corresponding aldonic and saccharic acids. As a glucaric acid is there. But whenever this reaction takes place in the body, first of all, it is an alternative method of oxidation of glucose. So here the method is, pathway is uronic acid pathway. It is going to form glucouronic acid, which you have to remember. And this glucouronic acid plays a very, very important role in the degradation of heme. Very important. When heme, we know hemoglobin is the main respiratory pigment in the blood. So heme is synthesized also in the body, it is degraded also in the body. So when it is degraded, it is going to form bilirubin and bilirubinin, or the bile pigments you can say. So whenever bilirubin enters inside the liver, it undergoes detoxification, or you can say it is converted to form stracobilinogen and urobilinogen. So for that particular reaction, the molecule required is none other than glucouronic acid. So this is the most important significant feature of glucouronic acid, that this glucouronic acid is required in heme degradation, which again we will be discussing in heme metabolism also, and it is covered in physiology also. And second is, it is required in the synthesis of mucopolysaccharides too. Polysaccharides. So you just have to remember there is a difference between gluconic acid and glucouronic acid. Gluconic acid simple by mild oxidizing agents, glucouronic acid by uronic acid pathway. So this is what is oxidation. Then the third property which I discussed was reduction. Now see, whenever we talk about reduction, we know aldehyde is there. Aldehyde is always reduced to alcohols. Simple concept which you have studied in class 12th also. Aldehydes to alcohols. Right. So first of all, I can simply say that glucose, which is the aldohexose, it will be converted to sugar alcohol, which is sorbitol. Galactose, galactitol. In some books it is given as dulcitol also, it is one and the same thing. Mannose, mannitol. Fructose, again sorbitol. So what are these? These are the sugar alcohols. Again a very important question. They are the sugar alcohols which are produced from an aldehyde or a ketone by a simply reduction. Okay. And if we talk about the enzyme here, it will be simple, aldol reductase. Why reductase? Because the reduction is occurring. So the name of the enzyme here is aldol reductase. And clinically this reaction is very, very important. Now what is happening is, if we talk about glucose, this is the first reaction. So I can say that glucose is converted into sorbitol. Right? The name of the enzyme is again aldol reductase. Now first of all, we will take up with this reaction. Now what is happening is, what is the clinical correlation of this? If we talk about commonly, diabetic mellitus, what happens is, if a patient is diabetic, we know that in DM there is increased concentration of glucose, and I told you glucose is the main hero in the body. It is giving energy wherever it is there. So glucose is giving energy for the eyes also to contract, to relax, or to the eye muscle. So what is happening is that in the eye, if there is persistent hyperglycemia, increased concentration of glucose will lead to increased concentration of sorbitol, because sorbitol ka concentration will keep on increasing, and this sorbitol cannot cross the eye membrane. It is impermeable to the eye membrane. Right. So, since it cannot cross the eye membrane, it will start increasing in concentration. So, what will happen? It becomes like a balloon. Just when we fill air or when we fill water in balloon, if we try to fill in more of water and air, it bursts. So a kind of pressure is exerted in that balloon. So same is the case in eye. What happens is, increased concentration of sorbitol is going to increase the ocular pressure in the eye. And depending upon the severity of, that is why we always say, people say reversal of diabetes is there. But once diabetes crosses a particular stage, it is very difficult to reverse it. We can reduce it, but we cannot reverse it. So what happens is, increased concentration of sorbitol will increase the concentration, or it will increase the ocular pressure. So that pressure will actually try to affect the blood vessels. In that bargain, the blood vessels, you can say blood will ooze out from the capillaries. So it might lead to internal bleeding also, and it might lead to, you can say, retinal detachment, or you can say it is going to affect the vision. And it is one of the very, very important reasons that increased ocular pressure leads to the formation of cataract. And the cataract so formed by, you can say, increased concentration of sorbitol in diabetic patients is snowflakey cataract. Snowflakey. Yes, snowflake cataract. Because the image becomes blurry. It's like, this is snow when for some time we cannot see anything. It's like a kind of avalanche coming in front of our eyes. And this is one of the most important complications of diabetic retinopathy. Very, very important. Diabetic retinopathy. Right? So what is happening is, we can simply say that glucose, when the concentration of glucose is increasing, it is increasing the concentration of sorbitol also. In a normal individual, the reaction is taking place in a normal way. But in diabetics, increased concentration of glucose will lead to increased concentration of sorbitol, which is impermeable to the eye membrane, which will lead to increase in the ocular pressure, which will lead to the development of the cataract. And the cataract so formed in diabetic individuals is snowflakey cataract. And this is one of the most important major implications of diabetic retinopathy. Okay. Then second reaction is conversion of galactose, because galactose is a very important milk sugar. Okay. This galactose, again in the presence of the same enzyme, aldol reductase, it is going to form galactitol. Now see, whenever there is increase, because obviously what happens is galactose altogether has a different metabolism. So what happens, clinical correlation is that if there is increased concentration of galactose, if the concentration of galactose increases, obviously the deficient enzyme is just say GALT is there or GALC is there. So I can say whether GALT is absent or GALC is absent. Galactokinase or transferase, again there will be increased concentration of galactitol or dulcitol. Now again, increased concentration of galactitol is again going to disrupt the ocular pressure of the eye, and it will also lead to the formation of cataract. But here obviously the cataract has to be different because the sugar is different, its metabolism is different. So here the cataract produced will be basically bilateral cataract. So we call it as oil drop cataract or bilateral cataract. You are going to study these different type of cataracts in ophthalm also. Okay, bilateral cataract. But here I am just giving you a superficial difference between the cataracts in diabetic individuals and in galactosemia patients. Okay, so always remember in galactosemia, I'll just write like this. In galactosemia, the cataract will be bilateral or oil drop cataract, whereas in diabetic individuals, the cataract will be snowflakey or snowflake cataract. So these are the two very important sugar alcohols which are produced by the oxidation of glucose and galactose. Then third is if we talk about fructose, because fructose is also one of the very important ketonic sugar. But here what you have to remember is fructose will not require aldol reductase sabse pehle. Why? Because fructose is a ketonic sugar. No doubt fructose is going to form sorbitol. But here this sorbitol is required by the sperms for energy. And this pathway is also known as polyol pathway. So fructose is going to form sorbitol here, but this sorbitol is different. And if we talk about mannose, mannose forms mannitol, which plays a very important role in maintaining of the intracranial pressure, right? So fourth is mannose, which forms mannitol, right, for intracranial pressure. So these are the very important properties of the monosaccharides. First of all, first is the isomerism, second is oxidation, and third is reduction. Right, now in the next video of mine, I will be just discussing again because this chemistry actually I have divided into two videos. First video finishes here. In the second video, we will be continuing with again the chemistry of carbohydrates, where we will be discussing the other properties. Thank you.